minus 10 seconds. 9, 8, 7, 6, 5, 4, 3, 2, 1.
It's undeniable that the power the atom possesses is truly inconceivable. In the process of nuclear fission, the nuclear reaction that causes atomic explosions, temperatures of up to 2 million Kelvin are produced. That's roughly 2/5 the temperature of the surface of the sun, and it's just for one fission event. In the nuclear bomb, this process happens multiple times in a nuclear chain reaction, which leads to this. The power this great force possesses is undeniably the greatest mankind has ever had the ability to manipulate. While nuclear energy may have a bad reputation for its misuse past, we can use this for good. We can use nuclear energy as a possible resource for widespread, efficient, clean energy. Although the waste produced by nuclear energy power plants are harmful, and we admittedly have not come up with a way to dispose of it correctly, the benefits nuclear power plants can provide, such as replacing fossil fuels, abundant power that can last for centuries, and the reliability and safe operation under the correct supervision can have positive effects for the planet for centuries and provide accessible power to homes worldwide.
The atom was first proven to exist in 1897 by J.J. Thomson when he discovered the electron by experimenting with the cathode ray tube, otherwise known as a Crookes, which was named after the British chemist and physicist that invented the Crookes tube itself. However, the atom was actually first theorized in 5th century BC by Greek philosopher Democritus. Democritus was the first person to theorize the atom after splitting a rock into two and asked the question, was there a point where you can no longer split an object into two pieces? He coined this point to the atomos. English chemist John Dalton was the first person to officially piece it together and made the atomic theory in 1803, which consisted of 5 laws. Everything is made up of particles called atoms. Atoms are indestructible and cannot be changed. Elements are characterized by how much their atoms weigh. In chemical reactions, atoms come together in minuscule and whole number ratios. And finally, when elements react, the atoms inside might combine in more than one whole number ratios. Fast forward some years to 1897, back when J.J. Thomson discovered the electron, and in 1911, Ernest Rutherford, a former student of J.J. Thomson, along with Ernest Marsden and Hans Geiger, conducted experiments with alpha particles. Rutherford would shoot the alpha particles at solid substances such as gold foil and would record where the alpha particles would hit on a fluorescent screen behind the gold sheet. As they suspected, the particles would pass right through the gold sheet, but some would hit the sheet and then go back at an angle, and even with some bouncing right back. With this, Rutherford concluded that the atom was made of a positively charged nucleus with surrounding negative charges. These discoveries gave way to the idea to use these charges in elemental reactions for energy.
With the discovery of nuclear fission in 1938 and the self-sustaining chain reaction in 1939, the nuclear age had finally kicked off, with scientific breakthroughs occurring only years apart. While other nuclear reactors existed at the time, the Experimental Breeder Reactor 1, or EBR-1 for short, was the first nuclear power plant to generate usable electricity. Located in Butte County, Idaho, construction of the reactor began in late 1949 and began power operation on August 24, 1951. The EBR-1 was a liquid-cooled fast reactor made to show that the reactor can create more power than it consumed, and not only that, it also showed to produce more heat than the light water reactors it had at the time, and also showed to be way more sustainable over a long period of time. And only a few months after it began power operation, the EBR-1 on December 20th, 1951, was able to power an impressive 4 light bulbs. This was a pretty big deal at the time, and eventually the EBR-1 did go on to power the entire facility. And then a couple years later, the Obninsk power plant in Soviet Russia became the first power plant to provide power to the entire power grid. Despite advancements in nuclear technologies, it will be over 3 decades before nuclear power became a significant contributor to power. Fossil fuels dominated the power industry, with 91% of the United States power being generated by fossil fuels in the 1950s, and then jumping to 93% in the 1970s, with today being only a measly 81%. However, over the years, it became harder and harder to find a consistent supply of fossil fuels. The U.S. Department of Energy estimates we will run out of fossil fuels by 2060.
Sort of almost amongst the founder members of green thinking, because I produced the instruments that validated Rachel Carson's thesis about the damage done by pesticides and so on. And also I first found the CFCs in the atmosphere and started that. So I've got some pretty good, strong green original credentials.
There are currently 60 commercial power plants and 98 nuclear reactors in the United States and roughly 450 in the world, with France currently having the largest. In the United States, 90% of these reactors produce 807 kilowatt-hours, and that accounts for about 20% of the total electricity generated. Our newest power plant is named Watts Bar Unit 2 in Tennessee, which began running in 2016 and is currently still running, producing some of our electricity right at this very moment. Currently, there are 31 countries relying on nuclear power plants and only 5 relying on fossil fuels, with the other 159 relying on a variety. These 5 countries rely on fossil fuels for virtually 100% of their energy. In the long run, those relying on fossil fuels pay more than those relying on nuclear energy. It is true that the nuclear power plants cost more to build, but it is relatively cheaper to run. Even though the nuclear power plants cost more than they give you relatively more energy, the equivalent amount of fossil fuels. 1 pound of nuclear energy has about 1 million times the energy as the equivalent 1 pound of fossil fuel. Not only does it provide more energy, but it is so much better for the earth than the fossil fuels. Nuclear energy burns clean, which helps our environment because as of 2019, it was recorded that the hole in the ozone has reached its peak of 6.3 million square miles. There are currently 16 countries against using nuclear energy, some of those Australia, Austria, Denmark, Greece, Ireland, Italy, Portugal, Israel, Serbia, and Norway. Japan is currently also attempting to shut down their nuclear plants due to the incident in Fukushima with the tsunami wave that hit there on March 11, 2011, causing 4 of the 6 reactors to release radiation into the atmosphere and ocean. While other countries such as Ukraine, where the worst nuclear accident occurred, the Chernobyl disaster, 30 people were killed in a matter of 3 months when 4 reactors that had a flawed design began to emit radioactive gases into the atmosphere.
Uranium is the most used material in nuclear power plants and is the cause for the misconceptions that nuclear energy is a bad thing. This is being caused by the past incidents and disasters engraved into the minds of not only those that experienced it, but those that come to know and learn about these events. However, we must put these incidents behind us and simply learn from our mistakes, because if it was not for these events, we would be using more fossil fuels. Uranium emits a poisonous radon gas, which is dangerous to those mining it and can cause a disaster throughout the entire mine shaft. The uranium has to be heavily concentrated in order to use it in power plants, meaning that only a fraction of the raw material is actually usable, leading up to the fact that it is very expensive and time-consuming to harvest. However, there is an alternative. Using thorium is a much better option across the boards. It is much safer to mine due to its very low output of radioactive particles, and there is no concentration process in order to use it, meaning that we can produce way more energy using thorium than uranium. In fact, the energy output of 1 ton of thorium is equivalent to 200 tons of uranium, or 3.5 million tons of coal. Not only this, but after you use it, it produces very little waste, meaning it is much more manageable to dispose of.
The benefits we could be receiving if we switch from fossil fuels to nuclear energy would benefit us in almost every way imaginable. This barrier had been broken many years ago, we just don't know it yet, and hardly anyone has even realized that we've broken this great barrier in nuclear energy. We would be burning fewer fossil fuels and helping to better protect our Earth and everything living on it, including us. So as the human race, we need to do everything in our power to keep our planet as healthy as we can for as long as we can, and with this we can also imagine a world where the power is not a great bomb made of energy harnessed to kill millions of people, but in fact simply what's behind a light switch.